In this practical lab, we'll take a look to the static routing configuration together. We have 4 steps to configure for this lab, guys. In the first step, lab is saying us to configure gig00 interface of all routers with proper IP address compatible with their names. So we need to find a compatible IP address for the gig00 interface, and that should be compatible with the names of the routers too also. In the second step, lab says us to configure gig0, 1 and 2 interfaces of all routers as shown in the figure. And in the third step, we are going to configure static routing and provide full connectivity between all networking devices as is shown in the figure. And in the fourth step, we need to run show IP protocols and show IP route commands, and we need to check the output. Okay, let's go. Let's talk something about the topology too. We have 4 PCs, PC 1, 3, and 1, 2, 3, and 4. We have 4 switches, switch 1, 2, 3, 4, and we have 4 routers, router 1, 2, 3, and 4. We have different networks. As you can see that we have 10, 41, 11 network for here, 32 network for here, 44 network for here, and 22 network for here. And we have different networks between the routers too also. We have 10, 41, 12 network for here between router 1 and 2. We have 13, we have 24, and we have 34 between router 3 and router 4. As you can see that in the picture, we have the IP addresses or the switches and the subnet masks also. So what that does mean? That means that we can derive something, huh? I think. Could we define the network IDs for here using this information? I think yes. 1041 11.5/30/24 means we have a network ID of 11.0 for here, right? Also 22.0 and 44.0 and 23.0 for the portion of this network. So what that does mean? If I have a network ID of 11.0/24, that means I can use this IP range for this network. 1 through 254, right? But because of question saying us that all routers' gig00 interface should have a compatible IP address with their names, I need to assign the 11.1 IP address for gig00 because this is router 1. I need to assign the 33.3 for here because this is router 3. I'm just changing the last octet, as you can see that. I need to use 22.2 and 40.4, 44.4 for here. And please pay attention that these IP addresses that I have given to the Geek00 ports should be configured as the default gateway on our PCs. Gateway of this PC should be this IP address, right? Alright, let's go and configure the Geek00 interfaces as shown in the figure. I'm gonna configure 11.1 for router 1. I'm gonna configure 33.3 for router 3, 44.4 for router 4, and 22.2 for router 2. And let's go! Packet tracer time. Here is my topology that I draw in Packet Tracer, and I'm going to configure the Geek00 interfaces of the routers. Let's go. I'm in router 1 and I'm getting into the enable mode from now on, beginning just from now. I'm not gonna explain that how I go into the enable mode, why I join to the config mode, because I talked about a lot of times what these commands are doing. You can check the previous labs and learn about them also, but from here, beginning from here, I'm not gonna tell you that, hey guys, enable command makes us moving from user mode to privileged exec mode. Alright, because you know it anymore. Okay. Let's get into the config mode and let's say that interface Geek00, and I'm gonna give the IP address of 10.41.11.1 for router 1. But what I've forgotten here, iOS warns me that that's an incomplete command. iOS is right because I didn't give the subnet mask, so I'm giving my subnet mask too. /24, which means 255.255.255.0. Enter. And please don't forget to say no shot. Router 1 is okay. Now I'm gonna configure router 2. CLI enable config interface Geek00 IP address 10.41.22.255.255.255.0 and no shot. Pretty cool. It's time to take a look to the router 3 too. CLI enable conf interface Geek00 IP address 10.41.32.33.3 and 255.255.255.0 and no shot. I'm in the router for lastly. And no shot. It's okay. That's pretty cool. And I configured all my Gig00 interface of all routers with proper IP address, and they are compatible with their names. Woo! That's great. The first action was taken, and let's get into the second step. In the second step, we need to configure Gig01 and 02 interfaces of routers as shown in the figure. But what we see in the figure, here just you can see the network IDs. For example, the network ID of here is 10.41.12.0 and /24. But with that format, something is writing on the interfaces. There are some labels. That one means that use that one for this interface. The last octet will be 1. That 2 means use 10.41.12.2 for this interface. Okay. So now it's time to configure these interfaces on all routers as shown in the figure. Please keep in mind that the last octet will be 1 for router 1, 2 for router 2, 3 for router 3, and 4 for router 4. Packet tracer time. And let's get into the Gig01 interface first. Okay, it's time to take a look to the router phone 1 first. Interface Gig01. I need to configure an IP address of IP address 10.41.13 and 1. And no shot. Let's go to the interface Gig02, and my IP address for here will be 12.1. Okay. As you can see that Gig02 is 12.1 and Gig01 is 13.1. Pretty cool, pretty straightforward. There's no problem. We can easily implement the IP addresses as shown in the figure, right? So let's take a look to the router 2 now. In router 2, I'm going to configure 12.2 for Gig02 and 24.2 for Gig01. Let's go. Interface Gig02. .2 and no shot. Then I'll go to the gig 01. Gig 01. IP address will be this time 24.2 and no shot. All right. I'm seeing a problem, but I'm not gonna tell you that now. Let's go to the router 3 now. I'm in router 3, and let's go to the interface gig 01, which is gonna be IP address and no shot. And let's go to the interface gig 02, which will have an IP address of 34.3 and with a subnet mask of 255.255.255.0. And the last step is we are going to take a look to the router 4. Interface gig 01 will have an IP address of 24.4 no shot, and interface gig 02 will have an IP address of 34.4 and no shot. As I told you that I'm seeing a problem in the figure. Please pay attention that everywhere is in green. That means there's not a physical problem between that devices, but I have red dots between router 1 and router 2, which means there's a physical problem between these two routers. So to fix it, I need to check the configuration of gig 02 for both routers. Let's go gig 02. Please remember that to verify the interface configuration, I'm using show IP interface brief command. And as you can see that for gig 02, I have a problem. The problem is status of this port is still administratively down, which shows me that I forgot to type no shot. Gig 02 and no shot. And as you can see that line protocol on the interface gig 02 changed state to up, which means physical problem is not with us anymore and everywhere is green. And that means we have completed the second step too also. Alright, pretty cool. I know that that's not an easy lab for you guys, but you learn lots of things when you accomplish and when you learn the details of this lab. Alright, let's go with the third step. Third step tells us configure static routing on all routers to provide full connectivity between all PCs in the network. Da 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 da. That's the really most important part of the lab. And first, we need to understand what's going on. Okay. To configure a static route, for example, let's say that I'm going to configure a static route for router 3. But which networks should I teach to router 3? And where I'm going to send the packet, I have two questions. And for router 1, which networks should I teach for the router 1? And where I should send the packet? First, I need to define this. Then I'm gonna write the static routing commands to the routers. As you'll remember from our first sections, what I told you is routers already know the networks which they are directly connected. For example, router 3 is directly connected to here, here, and here. So, I don't need to say router 3 that, hey man, if you have a packet which destination is 33.0 network, send packet to somewhere. Because router already knows here. Router says that on my gig 00 interface, I have 33.0 network already. Let's take a look to the router 4. Router 4 is directly connected to here, here, and here. So I don't need to say to router 4, for example, if you have a packet which destination is 24.0 network, you need to send packet to some interface, because router 4 already knows that I have 24 network connected to my gig 01 interface. I don't need to learn it. Okay? So, I need to use static routing for router 3 to teach the networks that router 3 is not directly connected. So for router 3, I need to use static IP routing statements for these networks. 11, 12, 22, 24, and 44. Alright. Because router 3 is not directly connected to these networks, and router 3 doesn't know how to get these networks. So I'm gonna teach these networks to router 3 using the static IP configuration. Right. Let's say that what we have, let's take a look what we have for the router 1 also. For router 1, I need to use the static IP configuration for these networks. This is gonna be router 1. And I'm gonna use 33 34, 44, 24, and 22, right? I hope there is no problem about these steps and you can easily get this because that's really important portion of the static networking. And it's time to take a look for the router 2. Where router 2 is not directly connected are 11, 13, 33, 34, and 44. Okay, I completed this one too. And it's time to take a look for our last router, which is router 4. And for router 4, I need to use static IP routing statements for where? This, and this. Okay, there's no problem. And now I define that for which networks I'm gonna use static routing statements. For example, for router 1, I'm gonna get into router 1 and say this guy, hey man, hey router 1, if you have a packet which has a destination network ID of 10.41.33.0, send the packet to here. Okay, I'm gonna say the everything for this networks too. Hey router 1, if you have something that you don't know, send the packet to this guy. And I'm gonna get into the router 2, and I will say router 2 that, hey man, if you have packets which has a destination of this networks, send the packet to here. Here, I mean here. I'm gonna say router 4, send the packets here, and I'm gonna say router 3 to send the packets to here. So what I'm doing is, I'm covering all the network as you see with a circle. For example, if router 1 has a, for example, let's say that PC1 wants to communicate with PC2, packet will come to router 1. Router 1 will check the destination address and will see that that's 22.0 and will send the packet to here. Router 2 will get this packet and router 2 is directly connected here, as you know, and will forward the packet to the PC2 directly. But if PC1 wants to communicate with PC4, router 2 will also get the packet and send it to router 4. And because of router 4 is directly connected here, that's going to send the packet to the PC4. That's the logic behind this. Please pay attention that I would do this one too. I could go to the router 1 and say that, hey man, if somebody wants to go to 33.0, send packet directly here. That would also work. But for simplicity, I'm just defining one way as a circle, and I'm sending the packets on that way. You can also give it a try to sending for different points too. There's no problem about it. Alright, now it's time to go to the packet tracer again. And I will make our configurations that I talked about. Oh my god, my CLI is broken and it's okay right now. Okay, and let's go. Enable config. My static route config is like this. As you're gonna remember from our previous slides, it's IP route. IP route question mark. iOS says us also that write the destination prefix. Okay, for router 1, my destination prefixes are, this is the destination network subnet mask, and I'm gonna write the forwarding router's address where I'm gonna send the packet. Okay. Oh no, it's not okay. Sorry, so sorry. I'm configuring the router 1, so I don't need to teach this guide to 11 because it's directly connected. So I need to start with this maybe. These two. 44, 24, and 22. Here is my whole configuration for static route. Let's take a look at this portion. IP route 1041.22.0 and subnet mask of the destination network. Send the packet to 12.2, which is router 2. Alright, let's go to the router 2 now. In router 2, I'm gonna define 11, 13, 33, 34, and 44 as you remember. Because the other networks are directly connected and I don't need to teach them to router 2. IP route where I'm gonna send the packets from router 2 is this one, which is the IP address of the router 4. And I'm gonna configure this for 11, 13, 33, 34, and 44. Okay, cool. Hey guys, please warn me if I make something wrong, okay? Enable config IP routes. Come on man, what's going on with you? IP routes this is gonna be rather 1 this time. 12, 22, 24, and 44. Awesome. At least it looks awesome. I hope so. It's awesome. We are gonna check if there's something wrong or not in the last step. Enable IP route, send the packets to router 3 interface. Alright, I'm gonna also teach this guy, this network, also this network. Alright, it seems like everything is okay right now, but I should verify it. If all my configurations are okay, I should pass these tests. For example, I should ping PC2 from PC1, or I should ping PC4 from PC3, but I'm gonna use to ping from PC1 to PC4, for example. PC1's IP address is 11.5 and PC4's IP is 44.5. Let's go. Please work. Alright guys, no problem. If we have some problem about the configuration, we are gonna quickly troubleshoot it, and I'm gonna show you how we troubleshoot step by step, and we are gonna give a quick solution for the problem too also. But it's better that I prefer that it works. I need to show you this one too. I'm getting into the PC and I need to open command prompt to use the ping command on a PC. And here is my command. Ping 10 41 44.5 and enter. Please work, please work, please work, please work, please work, please work. It's not working. No. Here is the bad news. It's not working. Okay. That's really cool for me. You will learn something more. That means it's working anymore. We don't need to troubleshoot because it started working. I don't know why. Packet tracer sometimes may do some weird things like this, but our ping is working right now. So we don't need to troubleshoot. But I'm gonna try to ping from this guy to here too and check what's going on. Let's go command prompt and let me check the IP address. 33.5 and let's check it. It's working. It's working, guys. We don't need to worry about our configuration right now because I can ping the PCs from each other. That means I'm verifying my configuration. pretty cool, pretty straightforward. There's no problem seriously on my network now. Everyone can reach everywhere, it seems like. I don't know if there's a little problems with other devices, but I don't think so. But what if we would have a problem and how we could troubleshoot it? Let's take a look over at this. If I couldn't ping from PC1 to PC3, what I would do? The first thing I need to check is the default gateway of the PC1. Let's take a look to the default gateway. Default gateway is 10, 41, 11, and 1, which is the IP address of the Geek00 interface of my router. And first, I can take a look that if I have a connection to my default gateway or not by using pinging the default gateway. As you can see that there's no problem. I can ping my default gateway. If I couldn't ping my default gateway, if I wouldn't be able to ping my default gateway, I would check the Geek00 interface's IP configuration first. Okay. The second step that I can look at, if packet is reaching here, my gateway ping is successful, and if I wouldn't still ping the PC4 in here, what I should check is the IP address configuration of the interfaces and the static IP configurations also by using show IP route static command. Or I could also check this by using show run command too. As you can see that from the output, I have my static routes for 22, okay, 24, okay, 32 and 34 and 44 for the router 1. Which means I have a static route for my destination network that PC4 belongs to. That's great, that's cool, and my configuration is working, and it's time to check the third step too. And in the last step, MATLAB says me that run the show IP protocols and show IP route commands and check the output. Let's use the show IP protocols command on router 1. Enter. Oops. Oops, I cannot see anything. What's going on? What's going on, man? We made something wrong. No. Actually, we didn't make something wrong. Everything is right. This is the output that I accept to see because I didn't use any dynamic routing protocols. Because of I didn't use any dynamic routing protocols, show IP protocols output is actually nothing because I used static routing. And the second command is show IP route. And as you can see that I had directly connected interfaces automatically appearing on my router, and the local interface of the router is appearing automatically too also. And these lines are appearing after the configuration of the static route that we made on our previous steps.